Hey guys, in this video we're going to look at how to find the minimum distance from a point to a line. Now, to understand the concepts taught in this video, you need to have an understanding of the scalar or dot product, and you also need to understand that when the scalar or dot product is 0, that two lines are perpendicular to each other. Let's get into the question. Find the minimum distance from the point A31 to the line with vector equation this. Now, I've just drawn up any generic line here. That's the blue line over there, and that'll represent this line over here. That's not necessarily how this line looks. Then I'm going to bring up any generic point A. Now, the shortest distance between a point and a line is via a straight line, and that line must be perpendicular. So if I head straight towards the line there, I'll hit a point M, which is the closest point on the line to my point A. So then we'll have this vector, the length of this vector here is going to be the shortest distance from the point A to my line here. So we need to describe this vector MA in terms of the equation of the line and in terms of the position vector of A. So we know that this red line represents any point on this line here. So we're going to call this point RM if you want. And what we're going to do is we're going to go in the opposite direction of the line, so minus RA, and then we're going to go plus OA there. So that OA there gives us this vector here. Let's just think about one more bit of information that I want. I want to know what the direction of this line is, and obviously we know that the direction of the line is given by this part of the equation over there. So the direction of the line, I'm going to call it V, and the direction of this line is going to be -1, -1. So how do we get this vector MA? Well, like I said before, we're going to go from M to O, and then we're going to go from O to A. And that gives us this equation over here. What does MO equal? Well, it's going to be the negative of whatever this vector is, because it's traveling in the opposite direction of that vector over there. So to go from M to O, it's going to be minus RA. So that's going to be minus RA over there. And then we have to go from O to A. Now A has position vector 3, 1, so we have to add on 3, 1 there. And when you combine these two together and simplify it, you'll get 2 minus lambda and 3 minus lambda. That's what vector MA represents. Now we also know that vector MA must be perpendicular to V. So when we take the dot product of MA and V, we should end up with 0, which is this result over here. So when we take the dot product, it's just -1 times all of this, plus -1 times all of that. And that gives me -2 plus lambda, -3 plus lambda equals 0. And we'll solve for lambda. So lambda here is 2.5. This means that when lambda is 2.5, we can figure out what our value of M is. Or we could substitute 2.5 into MA, and we can figure out what the position vector of MA would be. When we do that, we're going to get MA is -0.5 and 0.5. That's what this vector here represents going from M to A. It's going to be the vector -0.5, 0.5. Now, we don't care what the vector is. We want to know what is the minimum distance. So we want to find out what's the length of this vector over here. How do we find the length of the vector? Well, we just take the modulus of that vector. So when we take the modulus, we'll sum the square of each component and then square root that result. So we'll sum the square of each component and then we'll square root that result. And that gives us a minimum distance of root 2 on 2.